All right, how's it going today, everybody? Today we will be covering Notes 9.1 Prisms and Cylinders. So, to start it off, we first have to understand that there's a difference between two-dimensional and three-dimensional, right? And obviously, if you think about movies and all that stuff, there is a big difference between two-dimensional and three-dimensional. But in geometry, of course, we have two-dimensional shapes, three-dimensional shapes. So 3D objects, flat surfaces, basically. So when you have a two-dimensional shape, there's a couple of things about it. First of all, it can be seen on paper very easily, right? But it's flat. Uh, if it's a circle like the one that we have here, we can find a radius for it, of course. And the biggest thing is it has an area, so it has a radius, right? If it's a circle, but most importantly, I can find how much space is inside this very flat surface here. And it's basically when we do area, we're trying to figure out how many squares would fit in there. I know it's a circle, but I could do area is equal to pi radius squared. Remember, this is from the last unit. Very important formula there for us. And even, of course, if it were a square or some sort of rectangle, well, remember, there's a base, there's a height, and area would just be base times height. We're always trying to multiply two things. Even here, we're multiplying two things because of the power of two. But that's what we mean, right? When you're talking about a two-dimensional object like we have here or here, the idea is it's a flat surface, so the only thing I can do is find area. Now, when you're dealing with a 3D object, of course, so here we have a 3D object, that could be something like this marker right here, right? The fact that I can hold it, it's a 3D object that I can look at. It's not just drawn on a piece of paper. That's what makes this a 3D object in this case. In fact, it's kind of like a cylinder if you think about this marker here, where it has a base at the bottom, a matching base on the top, and then there's the distance between these two bases as I'm holding here. So that's the difference, right? So a 3D object can be held. So it's a 3D object. It has a radius, but right, if it's a ball or something else, it could also have a height, just like we saw right now with the cylinder. But most importantly, this is the big thing. If it's two-dimensional, only area can be found. If it's three-dimensional, we can start looking for volume. Remember, volume is the amount of space it takes up in real life. So for instance, if I had this cylinder right here, so let me highlight this circle and highlight this one right here. Those are the two bases it has. This right here, look, the distance from here to here would be the height. There's that radius they talked about earlier. But the idea is I want to know how much soup fits in that can. Or if it's a soda can, I want to know how much soda can actually fit in there. Same thing with a cone, right? If you're thinking about an ice cream cone, we would want to know how much space is in there, how much ice cream we could fit in there. But look at that. There's your radius again. The height this time goes right to the top, right to the edge there of the cone. And of course, in a sphere, yes, a sphere is basically just a full-on circle like a basketball, baseball. But notice how we would still have a radius there. Now, this one doesn't really have height because it's not something, I don't have two bases or I don't have a tip for the cone there. But in a sphere, these are the things we're always looking for. So radius is a big thing, even with volume, just like it was when we were doing area of a circle as well. But again, a 3D object versus a flat surface. Now, what we need to understand is when you do have a 3D object, if we slice the 3D object, it'd be nice to know what kind of shape comes out of it. Like if I were to take out, right, like a little slice. So here I have, look, it's a 3D object because it is full. But what would happen if all I did was cut this thing and I took out one tiny little slice? The question is, what shape would I see here? Like this one would be a rectangle, right? If I take off this one little slice from it. So we call that cross sections. Think of this as Fruit Ninja, right? If many of you have played that game in the past, very long time ago, with Fruit Ninja, we're like slicing all these fruits, right? So the question is, if I were to slice this way, so look at the cross section. This is the slice right here. So as I slice through it, the question is, well, what shape would come out of that little slice, right? If I take that little shape out, what does it look like? Well, in this case, the slice, the cross section, would be a circle, right? If we look at it there, look, we can kind of see it. That's why this is kind of nice with the whole color and all. But the cross section in this case would be a circle. Now that this can happen in a lot of different ways. Cross section, we are looking at one slice of the 3D object. Now, we could have sliced it in a bunch of different ways, right? I mean, think about Fruit Ninja there, of course. We could slice it side to side, up and down, diagonally, and we would get different shapes from it. So they're always going to ask, when they ask this question about cross sections, they're always going to give you a heads up and say, we want you to slice it a certain way. In fact, we're going to see that right now with these first few examples. So when I look at the first few examples, it says, name the cross section of the given solid, AKA, when I slice this thing, what's going to come out of it? So here we're going to be doing a horizontal cross section. Horizontal means I'm slicing side to side. Well, think about it. If I were to cut right here, well, if it's a cone, we know what shape is we're dealing with here. Look at that shape right there. Here's the slice. The slice would just be a circle. So that's my cross section, a circle. See, plain and simple. Now, if you look at this one, you might say, oh, it's a circle also, but look at how we made the cut. When we said vertical, vertical means that we're making the slice like this, up and down. So it's like I'm slicing it from the top to the bottom. And if I were to pull this out and actually see what this slice is, well, look, we have a line there, a line there. Well, it has to match. So there's got to be another line down there and right there. So the slice that we would pull out of this thing is basically just a rectangle. Look at that. So that's what they mean by cross section. They're asking, all right, if you make a cut, depending on how you make the cut, you're going to get a different little slice coming out of it. Now, this is a sphere, and we're going to cut it horizontally. Again, that means side to side. So if I slash through, right, Fruit Ninja style, and then I look at the cut that I made, then, of course, I mean, we can see it right here. It's actually in the shape of a circle. That would be the slice that we're looking at right there. So it would be a circle for this one as well. All right, so let's see if you truly understood this. Let's pause the video for a moment so that you can try these here. Now, don't forget, they're letting you know what kind of cut you're going to be making. So let's think outside the box and see what shapes you can come up with. So let's pause the video. Try numbers 4, 5, and 6. All right, now that you've had a moment to try it out, let's see how you did. So it says I'm making a horizontal slice this way. Well, think about it. If I'm going side to side, all I have to do is look at the top. Look at the top right there. This slice would go through all the way. So that means if I'm going side to side, then the slice that I'm looking at is just a circle. Now, this is a sphere. They said, hey, you're going to make your cut from top to bottom. Well, think about it. When I make that cut right there, that slice that comes out is, there you guessed it again, just another circle. I mean, for a sphere, pretty much anywhere you make a cut, it's going to be a circle. And I understand that we have a circle up on top, and you might say, oh, my slice is going to be a circle also. But notice, we're making the cut top to bottom. And if you're making the cut top to bottom, and I take this slice out, remember, I'm not slicing like this, so I'm not going to see any circles. If you think about it, that cut would end up being a triangle, and maybe not like this, right? Based on this picture, it would look more like this one because I'm slicing straight down. So when I pull that half out, this is what I would end up seeing. It's just a triangle. All right, so we talked about cross sections, right? When we slice through it, we want to know what kind of shape is going to come out of it. But now let's look at the next page here. And we need to talk about two different things. Now, we have something called a prism, and of course, we have something called a cylinder. Now, these are all words from your past, back in your middle school days, of course. It's been a while, but these are some of the words from our past. Now, a prism. A prism is just a box. And if you've ever shipped anything interesting where you have a triangular box, well, we know those exist as well. But that's what a prism is. A prism is just a box. A cylinder, on the other hand, right? Think of it as a soda can and everything else that we've dealt with when it comes to cylinders. But again, notice the base here. Here in a cylinder, we're dealing with circles. Yet on the other hand, when I have a box, see, this could be the base, but then there's a matching base right on top. Now, this one's the only one you have to watch out for, because if you say, oh, the bottom is the base, but there's no matching one on top. The only shape that actually matches with each other in this triangular box is this. This triangle matches perfectly with this one. See, they would be the bases. And it's one of the things that we're always doing when we're looking, whether you're looking at a prism or a cylinder, we're always looking for who's the base. And so that's what they're going to talk about here. Bases versus lateral faces. The cylinder, the bases area the circular parts. The bases are the circular part. So this is a base. And then, of course, we have a matching one on the other side. That's how we recognize bases. It says prisms. The bases are the blank and blank faces. So we're going to say the bases are the top for now and bottom faces. Now, the thing is, see, it's not always the case. This is a base. That's not top or bottom unless I flip it over. So technically, I guess it can be. And this is a base. And then here, this is a base. And this is a base. Now, height is the last thing that we need to mention. And notice what it says. The height of the solid. It is the distance from base to base. So that's why it is very important that we understand who the bases are so that I can find the height between them. So you see this distance right here from one base to the other, that's the height. And I know we're used to seeing height as up and down. Look at this one right here. From here to here, from one base to the other, that's the height. But on this one, where they kind of are, it's laying down from base to base, this would be the height for that part right there. So the height isn't always top to bottom. Please understand that. They're going to flip these 3D objects around to try to get you, but that's what we're looking for. So notice they give you a little clue here for the height, how to find it. Highlight the two bases. It's the line segment connecting the two bases. So we're always looking for the line that connects the bases. So let me show you here. When you're looking at example number 2, it says, shade the bases of the solid. So have something to shade with, highlighter, color pencil, anything you have, and label an H for the height and name the solid. All right. Now, when you have a box, you can make the bottom your base. You can even make the sides the bases, the front and the back. It's a box, so it doesn't matter. So I'm going to pick the bottom. And so there's the matching base. Now, remember, bases have to be congruent to each other. So it says shade the bases, done. Label the H for the height. Well, the height is from one base to the other. There's my height. Okay, I did part B, and then it says name the solid. Well, we definitely know this is a prism because it is a box. So we call it a prism right away. But if I look at the shape at the bottom, look at that. This side is equal, this side is equal, this side is equal. All four sides are equal. That's why you have to know your shapes. There's only one shape where all four sides are equal to each other, and that's a square. So this is a square prism. Now, when I look at this one over here, I have to find two sides that are exactly the same length. Now, notice the other thing about bases, they never touch. That's why there's a height between them. So they should never be touching, which is why the only bases that I could look at in this picture number 2 is this top one with this bottom one. There is no contact between them. They are parallel to each other. And so if that's the case, these are my bases. And guess what? This right here, the distance between them is my height. So now because this is a box, they want me to name it. Well, it's definitely a prism because that's what we call it when it's some sort of box. But in this case, because it's a triangle, then this one is a triangular prism. I know we didn't say squarangular or anything like that, just a square prism. This is a triangular prism. And finally, we have this one here. Now, when I look at this side and this side, look at that perfect match. That's how I know those are my bases, which means the height is the distance between them. So you see how that's different from the picture we had way up at the top there for that cylinder. The bases were top and bottom. Well, in this case, the bases are on the sides, and that's okay. And this is just a cylinder, like it says on the top. We don't call it a prism because it's not a box, it's a cylinder instead. All right, we'll take a moment. It's time for you to try these problems down here at the bottom. 1, 2, 3, and 4 there. So give them a try. Do the same thing we did. Shade the bases, label the height, and name the solid. So let's pause the video one more time so you can try these out. All right, now that you've had the opportunity to try these out, it's time to check your answers. So there they are. Obviously, the first one was a cylinder. Again, the shading should have been there. You should have labeled your height. Now, notice this. I did want to mention this very quickly. These two sides are equal according to the marks, but these are different sizes, and they're equal to each other. That's why this is not a square prism. It's a rectangle. So we call that a rectangular prism. On the other hand, when you do number 3, all 4 sides are equal to each other. And if all 4 sides are equal to each other, well, then this one is a square. So, but notice, even if you call it a square prism, you can also still call it a rectangular prism because all squares are technically rectangles. But I would not be able to call number 2 over here a square prism. And of course, you have a triangular prism there with number 4. All right, so now let's start talking about how do we find the space inside of these objects, right? If this is a soda can, I want to know how much space is inside so I could fill it up with soda. If I'm shipping a packet, right, a package that's in a box, well, I need to know how much space is in there so that I can find out whether or not what I'm shipping is going to fit in there or not. So things like that, that's called volume, of course. And so here we go. We're going to start off with the volume of a cylinder. Now, the volume of any shape is the amount of space inside of a solid. That's where we're looking for. So let me start backwards here. See, we have like a soda can here, and I want to know how much space is in there. So one of the techniques that they used to do back in the day, right, before they figured stuff out, is they basically took a figure and sliced it thin. Like this one has 11 slices. So it's like they made a cut and then they took it out, a super thin little slice. But what they're saying is, okay, if there's 11 slices stacked up together, they want to know, well, how much is each slice? So now I have to come over here. Notice when I talk about a single slice, right? This is the cross section here. This is why we talked about that vocab. This is my cross section. And we see that it's a circle, which is why we're going to do the area of a circle. A is equal to pi radius squared. Now, luckily, they did give me the radius. They said the radius is 7. So then it's pi times 7 squared, which is 49 pi. And of course, because that would be the area of that circle. Now, sometimes it is helpful if we actually turn it into a decimal. So we're going to be practicing both today, turning it into decimals as well. And so just remember, this is the exact value. And then I'm going to go 49 times 3.14. So if they want an exact value, I would have been done. If they want a decimal, now I have it. So it's 153.86 units to the power of 2 because area is always to the power of 2. Now, here's the thing. One little slice, that's the area for it. But then if you notice, they said, hey, look, now we're going to put 4 of these slices together to start creating a 3D object. And because it became a 3D object, now we're going to talk about volume because it's a 3D object. Well, I already know what the area is. The area was 153.86. And because it's 4 of them together, then I'm just going to multiply it by 4 because there's 4 of them there. So I let the calculator take over and I get 615.44 units. Now remember, this is now a 3D object. Notice how our unit has changed. When we did area, we always gave it a power 2 because it's a flat surface. This is now a 3D object, so my unit is to the power of 3. And look, this is the exact same circle. It has that same radius of 7, just like all of these right here did. But this time they said, hey, we're going to stack 11 of them together. And if they're going to stack 11 of them together and I want to find, well, how much space is that now, right? I'm still going to use the area of that very flat surface, the area of the base, we're going to call it. But now I'm going to multiply it by 11, which is our brand new height. That's how many they stack together. And so according to the calculator, that's 1,692.46. Of course, we're going to say unit to the power of 3 because now we have a 3D object. And so that leads to the formula for volume, and actually the formula for volume of any shape we throw at you, because I can cut any shape into little slices. Once I have the area of the slice, all I have to do is multiply it by how high they're stacking them together. So volume, here it is. Volume is equal to capital B. Now understand one thing. This is the area of the base, aka the area of the slice, right? Whatever you sliced out, that's the area of it. And then all I have to do is multiply it with the height. And that's how many they stack together. Well, the H is our height. Now, remember what they told us earlier, though? The height is the distance from one base to the other. Okay? All right. Well, let's put this into practice. Let's see if you kind of got the idea here. Now, we do have to be careful on this one. Notice the 12 is all of this. And we don't use the diameter. Remember, so they said the diameter is 12. Remember, for the radius, you just took a test on this. The radius is then 6. The radius is always smaller by half because this right here is the radius, which is why it should be half of it. And of course, if this right here is my base, right? The circle is my base. Well, here's the other one. Then I'm going to need a height. Well, the height is right here. 11 is the height because that's how far it is from one base to the other. Remember, height isn't always up and down. All right, here we go. When you do volume, you always find the area of the base, which don't forget is a circle. So it's pi radius squared. Well, we already know the radius. So my capital B is pi times 6 to the power of 2, which is 36 pi. There's my capital B. Again, I'm not going to worry about pi. In fact, they said leave it as pi. Now here comes volume. Volume is capital B times H. Well, that's why you just found your capital B so that you can use this. So don't forget, when you're doing volume, you're actually using two formulas. I have my 36 pi that we just found, and I'm going to multiply it with the height. Well, don't forget the height is here, 11. So we plug that in. And with your calculator eyes up, this is probably the most important thing because people tend to forget. 36 times 11, notice how I didn't put a pi in it, is 396. So when I multiplied these two, that was 396 but don't forget to bring the pi. And this is feet to the power of 3. And there is my exact answer. Because we haven't rounded, we haven't done anything. But I do have to mention that when you do your assignment on Big Ideas Math, they might be asking you to give a decimal. So if you look at the calculator, you just multiply 396 times 3.14, and there it is as a decimal, 1243.44. So 1243.44 feet to the power of 3, because once again, it's an volume. This is now an approximation because it's not exact. It's an approximation because we use the decimal for it. All right. The process, the procedure, it doesn't change. It never changes. Here we go again. So here we have a can of soup, right? And when I'm looking at this can of soup here, it says, how much soup does the can contain? That's a volume question. But when you read it carefully, they said the diameter is 3 inches. All right, well, we don't do diameter. We don't work with that. We said if the diameter is 3, my radius is 3 divided by 2. You just have to cut it in half. So then it's 1.5. That's the radius. That's from here to here. That's what we're looking for when we talk about radius. They also said that the height of the can is 5 inches. All right, well, we know the height. The height is 5. I have everything I need. The only 2 things I ever need for cylinder is radius and height. And here's the first thing we do. Capital B, pi radius squared. Well, my radius is 1.5, so throw it in there. And then let the calculator do that one for you there. It's a little weird. 1.5 to the power of 2, 2.25. 2.25. Don't forget that pi, of course. Now that's the area of the base. Now here comes the official volume. Volume is equal to capital B times H. So then that's, look, we just found it. 2.25 pi. And then it says, give me the H. Well, you already have it right there. So times the 5. And when you're doing this, don't forget, you're really just multiplying the numbers. You're going to leave pi alone. You're just multiplying the 2.25 times 5. Look at that, 1125. So there's my volume. 11.25 pi. What was the unit? It was inches to the power of 3. There is my exact answer, just like they wanted. But like I said, if they ask you to multiply and give a decimal, there it is, 1125 times 3.14. So my volume would be 35.325 inches cubed, of course. All right, so there you go. There's our volume for us for that can of soup. That's how much space is in there. All right, let's keep it going here. For number 3, it says find the volume of the cylinder with a radius of 4. Hey, that's kind of nice. Look, we don't have to do anything to that 4. The big mistake for people that don't pay attention is that I always divide this by 2. No, you don't. You only divide by 2 if they gave you a diameter. This is a radius. That's all I need. I'm good to go. And then they said the height is 5. Now, they did ask us to draw a picture and label it. So here's the easiest way that I have found to draw a cylinder. Look, just draw yourself kind of like 2 eyeballs, one on top of the other, and then you just connect the edges. See, just like that, we have a cylinder. Now, let's bring the information where it belongs. They said the radius is 4. Okay, there's my 4. They said the height is 5. There's the 5. They wanted a picture. We gave it to them. It's ready to go. But here we go. Look, the routine doesn't change. I need the area of the base. And because it's a circle, I'm going with pi radius squared, which I already know is a 4. And 4 times 4 is not 8. It's 16 pi There you go. There's my capital B. Now I go right into my volume formula. Volume is equal to capital B times H. We already know my capital B. I'll throw that in there. And then I already know my height right here is 5, so I'll plug that in too. So volume is equal to 16 pi times the 5. So remember, I'm really just multiplying the 16 with the 5, and 16 times 5 is 80. So my volume is 80 pi yards to the power of 3. There's my exact. And as I've mentioned a few times, it's the third time we say it. If they ask for a decimal, then you go 80 times 3.14. Look at that, 251.2. 251.2 yards to the third. That's only if they ask for a decimal. All right, well, let's see. Now, this last one, though, on this part, does kind of change things up a little bit. It says, find the dimensions of a cylinder whose volume is 200 pi. So unlike the other questions, they already gave me the answer for volume. They said, draw and label a cylinder. All right, let's try that again. Remember, kind of like drawing an eyeball. One on top of the other there. Connect the edges. All right, here we go. There's the radius they want. There's the height. See, I couldn't put numbers because I have no idea what it is. And then they started me off with volume. V is capital B times H. They told me this is 200 pi. We know the capital B is technically pi radius squared. And then, of course, we have H. Now, we have two unknowns, and that's all right. They said to find the answer. They said, tell me an R and tell me an H. They just want to know. And it could be any numbers. So we'll find out right now. What I can do, though, is I can divide. Look, I can get rid of this pi right here. But what do I do to one side? I do to the other. And just like that, those pi's are officially gone. All right, so now here is where I can make my life a lot easier. I get to pick any number I want because they didn't give me any other information. So because I'm going to pick any number, I'm going to pick the number for R because it has a power of 2. And since it's 200, I'm going to keep it nice and simple. I'm going to pick something like a 5. So let's see what happens. 200 is equal to 5 squared times H. Now, I'm not picking an H. I'm going to solve for it. Notice I picked one of my letters, but I'm going to solve for the other one that belongs with it. All right, let's see what we get. 5 squared is 25. There's the H. Yeah, you see, this is why I chose the number 5. Anything that ends in 0 or a 5, 5 is a good choice there because we know it'll divide nicely. So 20 divided by 25 is 8. And look at that. Just like that, we now know that if my R is 5, the H has to be the number 8. Now, I could have picked any number here. Just 5 worked out nicely for us. All right, and finally, the last thing we have to do is how to find the volume of a prism. Now, the idea is the same. In fact, look at the formula for the volume of a prism. Volume is equal to, all right, here comes the big difference. Remember, cylinder was capital B times H. So when I do the volume of a prism, volume is equal to capital B times H. See, it's the same thing. B is the area of the base. What you have to understand is they're going to keep changing the base. I mean, look at this one. If it's one little Lego, now we're going to pretend like it's flat, okay? If this is a four-sided figure, to find the area of one Lego, pretending it's flat, A is equal to base times height. All I have to do is multiply two numbers. Well, look, I have two numbers right there. So 2 times 2, 4. There's the area of that one Lego. So the area of the base is 4, right? Well, now I have two Legos stacked with each other. Well, then I already know that one of them is 4. But because I stacked two of them and I'm creating a 3D object, then I'm going to multiply by 2 because that's my height. 4 times 2 is 8. That would be the volume of two Legos stacked together. And then the last one is, well, what if I stack, let's see, 1, 2, 3, 4, 5, 6? See, there's my height of 6. But because each one, right, the area of the base, the capital B was 4. I know they use capital A here, but capital B is 4. Then the area of the base is 4, but I'm going to multiply it with the height. And 4 times 6 is just a 24. Now, these are kind of nice because you don't have to worry about pi being involved. But that's the idea for the volume of a prism. As soon as you're dealing with a box, we find the area of the base, like I did here for one Lego, and then I use that same number and I multiply it by the height every single time. All right, here we go. Last problems to get us ready here. All right. So what shapes are the bases? When I look here, the only two bases that are exactly the same is this one and this one. So the shape of the base in this case is a triangle. What is the height of the prism? Well, the height of the prism is the distance between them. So it could be any one of these lines, right? All of these are the distance between them. Well, this is the only one with an actual number, so the height is 16. All right, but look at your base. Your base is a triangle, and I see a 90 right there. There's my base. There's a 90. There's a 12 on this side. There's a 15 on this side, but there's a 9 on this side. Now remember, when you find the area of a triangle, according to what we learned in the past, yes, it's base times height, but I have to cut it in half. It's the only time we ever do that. But there's 3 numbers here. You have to pick carefully. And so here is how you do that. This is where the 90 is, which means this side touches the 90. This side touches the 90. Then those are my 2 numbers that I'll be using. Remember, they're going to give you extra numbers to try to get you. Just don't fall for it. So it's 9 times 12 divided by 2. All right, let's find out what the calculator says for that. This is the area of the base, or the area of a triangle. All right, here we go. So 9 times 12. I'm going to divide that by 2. So my area is 54. That's the area of the base. All right, well, so there's my capital B. Okay. Well, now it says you're going to do volume is next. Well, volume is capital B times H. Well, we already know what capital B is. It's right here. It's 54. So it's 54. And then all I need is a height. Well, we have the height right here. It's 16. Remember, there's no pi here. There's no circle. Don't bring it in if you don't need to. So 54 times 16. And there it is. Volume is officially 864. And here it comes. Centimeters to the power of 3. All right. All right, let's keep it going. Remember, you shade the bases. Now here I can shade a bunch of different things. Let's see. In fact, I'm going to shade the bottom here as my base, which means I should be shading in this top one. So those are my 2 bases, top and bottom. And of course, it is a rectangle. So this is a rectangular prism. Says, what's the height? Well, what that means, this is a height. This is a height. This is a height. And there it is. My height is 3. Now remember, eventually, I'm going to do volume here. Volume is equal to capital B times H. Well, you just found the H. I'm not going to use the number 3 over here. The number 3 has been used. Right, there's the 3 waiting. What I need is my capital B. All right, well, we know it's a 4-sided figure. It's just a rectangle. So let's bring in the numbers of that rectangle. Again, the 3 is not in the pink. Only the 4 and the 12 are. Well, then here we go. Capital B is 4 times 12. So capital B is 48. This is not a triangle. You don't cut it in half. That's it. There's the B. Well, then there's the 48 we just found. And all I do now is 48 times 3. And I get that volume is 144 meters to the power of 3. All right, last 2 problems to go. Now, here we go again with another triangle. Now, the triangles are the ones that always throw people off. That's why there's more of these on here. Notice it's not just this little triangle. No, it's the whole thing. And we go with this side right here as well. This is the other base of the triangle, of this triangular box. So we're going to say that what shapes are the bases? Triangles. It says, what's the height? Well, again, the height is from here to here, from here to here, or from here to here. Well, this is the one that has the number. So the height is 22. Remember, it's the distance between them. So that's why I was mentioning earlier, when you do volume, capital B times H, we already know that we're going to use the 22 here. So I should not use it when I find my capital B. Again, it should not be a part of that at all. So let's find that capital B because we need it. But 22 is out. You can't bring the 22 into the capital B. Keep that in mind. Now, when I look at this triangle, notice there's actually 4 numbers involved. So I'm going to try to draw that triangle the way I see it there, just so you can see where all the numbers go. So look, this side has a 49. The triangle on this side has a 23. On this side, it has a 35. And then it has a line right here with the 90. And it has a 15 right there. Look at this. This triangle has 4 numbers attached to it. But when you do your capital B of a triangle, remember, all I need are 2 numbers that I'm going to divide by 2. So the question is, well, what are the 2 numbers? Again, when you're doing area, there's only one thing you look for. Eyes up here. You look for the 90. When you're looking for the 90, this side touches the 90. This side touches the 90. And there you go. We have found the 2 numbers that I need. They gave us extra to get us. So 15 and 49. All right, we're going to let the calculator take over here. So let's see, 15 times 49. And then I'm going to divide that by 2. 367.5. And we're going to bring that in right here. If we can make it fit, there you go. And look, last thing, all I have to do is multiply that. 367.5 times 22. And there it is. Big volume for us. 8,085 is our volume here. So 8,085 centimeters cubed. All right. All right. And for the last 2 questions here. Determine which triangular prism has greater volume. And we're going to show all of our work. All right. Well, here we go. Look. When I look at this one, here's the base. Here's the matching base. Remember, bases have to match perfectly. Here's a base. Here's one that matches perfectly. So the next thing I'm going to do is I'm going to highlight the height, or label the height. So here's the distance between the 2 shaded. So there's the height for this one. Here's the distance between the 2. So this one right here is the height. Now remember, once I mark them as heights for between the bases for volume, I won't use that number again. See, I'm already going to start getting it ready. Volume is capital B times H. V is equal to, and I already know this one is 12. Just like here, volume is equal to capital B times H. Well, I already know my H is 12, so V is equal to, and then I'm just leave a space for now and put the 12 there. So that height is done. What I now need is the capital B. And capital B, again, it's a triangle. I multiply 2 numbers and divide it by 2. We only do that for triangles. And when I look at this triangle right here, look at that. There's the 90, which means it's the number 8 and the number 3. So 8 and 3, we let a calculator help us out if we need it. 8 times 3 is 24. Cut it in half. We're dealing with B is 12. And so I put a 12 right here. So my volume for this first triangular prism is 144 centimeters cubed. Now, when I look at this one, notice how they gave me 3 numbers to mess with me. And if you look at it, you go, wait a minute, there's no 90 in there. Well, there kind of is, right? We have to draw it ourselves here. Remember, I just need 2 numbers, and then I'll be able to find my capital B. Now, you might say, well, these two, that's not a 90. But if I were to stretch it out, we have a 90 right here. And sometimes they're going to do that to throw us off. So if you think about it, the 4 makes a 90 with this 6. They're basically saying this thing could have been drawn in here too. See, that would be a 6, and then there's your 90 in there as well. So this is 4 and 6. So 4 times 6 in this case is 24 also. Divided by 2 is 12. And so we get a 12 in here. And the volume is equal to 144 centimeters cubed as well. So notice how they gave us different information, but they said determine which triangular prism has greater volume. Well, if I'm looking at these two, is there one that has greater volume? Not at all, right? They have the same volume. Different dimensions, but they ended up with the exact same space on the inside. So a little bit of a trick question, I guess, huh? Trying to throw us off that one of them was going to be bigger, when in reality, they were actually the same. All right. With that said, everybody, try out today's classwork. And most importantly, make sure you work on Big Ideas Math. We're getting towards the end of the school year. Again, let's not let these grades slip. You can do this. Have a wonderful day.